Okay, so we're still on section 6.1 with Joshua and his crazy schemes, and I wanted to look at, scrolling ahead, right here, the expected value, that looks like E of x, the expected value or mean. These are the same, they mean the same thing. They are the same thing. And finding the standard deviation or sigma for a discrete probability distribution. So this is question 51 and 55. So question 51 says find the expected value of the money gained for Joshua's investment scheme. This is essentially asking how much money would he expect to make. And if you look at Joshua's thing here, you can just ignore this. So here's the amount of money he could make, and here's the probabilities. So if he did this over and over and over, how much would he make on average? What's the how much would you expect to make if you invested $10,000 or whatever with Joshua? And by the way, it never says how much he's putting in. If he's putting in $1, that's a really great investment scheme, but if he's putting in $100,000, that's kind of lame. Anyway, moving on. So to find the expected value, I'm going to do this by hand. Actually, I'm going to do it this way. Find the expected value. There's two ways to do this. You can do it on the calculator, or you can do it by hand. Doing it by hand for the expected value is not really that big a deal, so we will do that first. So the expected value of x equals the sum of every x times the probability of x. So in this case, we say the first x is negative $10,000, and the probability of that is 1/3, plus the next one, he could make $10,000, and the probability of making $10,000 was 50%, or 1/2. And then finally, he could make $50,000, and the probability that he makes $50,000 is 1/6. So when you work all of this out, you get to minus 3.33. I'm going to stop there. Plus, this one's easier, $5,000, plus 8. This one here, 8,333.33. So you're going to get different answers depending on how much you round here. There's a lot of rounding error going on here, but what you ultimately get if you have pure mathematics is $10,000. The expected value, you would expect to make $10,000 with Joshua. Again, I don't know, maybe he doesn't need to graduate from college. So that's the expected value of x. That is also called the mean. So, as a word of warning, if you do this on your calculator, you might get a different number because of the rounding errors. There is definitely some rounding error here, so be aware of that. Okay. Paused it so I could make a new pretty paint screen for you. So question 55, things get a little stickier. Compute the variance and standard deviation. So the variance, you can do this either by hand or on the calculator. Certainly using the calculator is a bit easier, and I recommend if you basically have to have a calculator for this class. It's so hard to do all the calculations by hand, and it's such a disadvantage when you know that all of your fellow classmates are doing this on the calculator. So look on page 270 for detailed instructions about how to do this on your calculator. Basically, I'm going to go through it here. You enter the data first. Well, how do you enter the data? Okay, you hit stat, the button on your calculator that hits stat. And then the first thing you'll see there is edit. So you go ahead and hit enter. Then you have to put the x data into L1 and the probability of x into L2. So you might have to clear your data first. And remember to put in the negative. Like the first x value is negative 10,000. And the negative button looks like this. And it's on the very bottom row of your calculator. So once you're done entering the data, then you just hit the stat button. And then you arrow over, use the arrow keys to get to calc. So arrow over, hit the calc button, and then hit enter. So then it'll give you one variable statistics. So hit enter on that one. Then you hit second function, which is yellow. I think it's yellow. It might be blue on the TI-84s. L1. Then you have to type in a comma. Second function L2. This is essentially saying my data x is in L1, but hey, wait, the probabilities are in x2. So don't forget to enter the comma, and then hit enter. The calculator will give you this. It'll give you x bar equals, and in my case, somehow my calculator is giving me 10,020. Again, this is a rounding error because I put in like 0.33 instead of 0.333333. The number of threes you put in can make a difference. And it gives you the standard deviation, sigma x. This is the standard deviation. In this case, mine gave me 20,009. I think it's supposed to be about 20,000. To get the variance, then you take the standard deviation that your calculator gives you and you square it. So I took this 20,009, squared it, and got this crazy number. Again, your book gives you 40, 4, 5, 6, 7, 8, like that. I'll add the commas. I think this is 40 million because of the rounding errors. But essentially what you want to do is enter the data into the calculator. This x bar is also the mean, it's also the expected value, and then the book gives you the standard deviation, and then you use that to get the variance. Notice that the SX is blank, the sample standard deviation. Your calculator does not do that because your calculator is smart and it knows that there's no sample here. Because you have the probabilities, it assumes you're dealing with a probability distribution, which is essentially the population of everything that could happen. So you have this probability with the population. So it just gives you the standard deviation sigma. Okay, so that's essentially the easy way to do it, is to put all the information into your calculator. It will give you x bar, which is the expected value or mean, and then it will also give you this sigma x, which is the standard deviation. You take that and you get the variance. So if you're doing it on your calculator, 1, enter the data. 2, find x bar, or the expected value of x. Oops, that was cool. E9x, what? And then 3, find sigma, which is the standard deviation, and 4, find the variance. If you're doing it by hand, it gets really hairy, and I'm going to do that for you now. If you're just using your calculator, you can stop watching right now. I'm going to go through doing this by hand, and if you're interested, you can watch this. But if you're not interested because you never plan on doing it by hand, I completely understand. So, by hand, here are the formulas. Expected value of x equals x times probability of x. We just did that. The variance, if you're doing it by hand, you find the variance next. The variance is sigma squared. That's the little symbol for the variance. It's the sum of x minus the mean squared times the probability of x. Okay, this is the part that's going to get tedious, but I can do it, and so can you. So the variance, sigma squared, is the sum of all the x minus the mean squared times the probability of x. So, in this case, first I'm going to just start with x minus the mean for each one. So for 10,000, for x equals negative 10,000, x minus the mean, let's go with the mean equals 10,000, equals negative 20,000. When x equals 10,000, x minus the mean is 10,000 minus 10,000 equals 0. When x is 50,000, x minus the mean, you can see why this is tedious, equals 40,000. Okay, that's x minus the mean. Okay, so now let's find x minus the mean squared. Okay, we're going to have a lot of zeros. Be prepared for many zeros. So this is 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's x minus the mean, that's 20,000 squared. Whew, 0 squared is 0. So now I'm taking this number, x minus the mean, and squaring it. So that's 16. 1, 2, 3, 4, 5, 6, 7, 8. Again, with the zeros. So many zeros. Okay, that's 1.6 billion. All right. Times, now we have to times that by the probability of x. So we multiply each one by the probability of x. So in this case, we're multiplying it by 1/3. Which is equal to 13, 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, and then I think it goes 0.3333 forever. The 0 is nice, isn't it? So this would be multiplying it by 1/2, but 0 times 1/2 is, is still 0. And this one, so we have x is 50,000, subtract the mean, that's 40, square it. Now we're multiplying it by 1/6. 1/6 equals 40, nope, it's 26, 2, 6, 1, 2, 3, 4, 5, 6, 7, 8, and then point, I think it goes 6666666. Okay. So, to get the sum of every x minus the mean squared times the probability of x, I add this column. So when you add these two together, you get approximately 4, 5, 6, 7, 8. Sorry, here it is. Looks like 400 million, which is what your book gives you, which is the variance. So it's fairly tedious, but it's not the worst calculation in the world. To find the standard deviation, you take the square root of the variance, which is the square root of this number, which should give us 20,000. Whew! It's such a pretty number that that's sort of satisfying, but otherwise this part was kind of ridiculous with all the zeros. So if you're doing it by hand, you can do it this way. This is the variance, right here, 400 million, with a standard deviation of 20,000. But really, again, it's probably easier to do all this on your calculator. So that is how it's two different ways to find the expected value, the standard deviation, and the variance for these discrete probability distributions. And for many of these, they won't have as many zeros as Josh in his investment scheme. So good luck with those.